there is some trade-offs that you make between scalability, decentralization, and security. And so that leads into our explorations today. What are the design trade-offs? Because we have a blockchain that establishes a generalizable data set, and we want to be able to do a certain amount of transactions, but we know that we want it to be decentralized. We also know that we want it to be secure. How should we design a blockchain in order to accomplish some of our goals? With Bitcoin, the goal was to accomplish digital money. With Ethereum, Cardano, Tezos, and a bunch of others, the goal is not to design a money. The goal is to design a computational resource. And that's kind of, that's where blockchain technology establishes this idea of being a new computing paradigm. We have the internet built in layers, the hardware link layer, the network layer, the transport and application layers. We're going to say somewhere in here, blockchains add a new layer of the internet. And with that comes some design trade-offs. Now let's look at a blockchain layer. Let's look at that, how that stack might be playing out. This is by no means established or standardized. It is far from it. But here's a general way of thinking about it. Layer 0, generally we can say that's the components of the internet, the thing that we're building off of. That's what enables everything else to move to run smoothly. Alternatively, if you were to have many Bitcoin, Ethereum, Cardano, Tezos like layer 1 blockchains, you may want to interconnect and weave those together. In some circumstances, those are called layer 0 blockchains, things that are trying to connect all other chains. And because it is a widely shared opinion that the future is multi-chain, that's going to say, well, we're all using blockchain here or some version of distributed ledger technology. How do we interconnect so that we have the benefits of one here and it can talk to one over here? Layer 1, like I mentioned, is like Bitcoin and Ethereum. This layer is in charge of how you design consensus processes, where you determine programming languages, block time, dispute resolution, rules and parameters that maintain the network's basic functionality. It's also known as the implementation layer. So that's layer 1, that's where we stand on, and then applications are built on top of it, scaling solutions are built on top of it. And because we have programmable, because this layer is programmable, it means that we can do some more interesting things on the upper layers. Layer 2 is most commonly referred to as the scalability layer. It removes some of the interactions from the base layer. And so as a result, smart contracts smart contracts deal primarily with deposits and withdrawals, and then ensure that a lot of the other transactions can occur off chain. So here's a decision. Do we want all transactions, computations, events to be recorded in an immutable ledger that's shared to everyone, that creates a larger and larger memory state? Or do we want to only keep the most important information on that layer 1 blockchain and then scale up the amount of transactions or the amount of events or the amount of computation on separate layers and then tie it back to layer 1? These things are being experimented with and are by no means figured out. Another important thing to note is we begin to say blockchain ecosystems because perhaps a solution at layer 1 establishes many different things to occur on layers above it. And in that way, you can have an entire ecosystem built on top of a layer 2 with all of its own applications and eventually tie back to layer 1. And it's a wide, it's a diverse, it's wild type of ecosystem, and those things are playing out. And then layer 3, we might call that the application user experience layer, the thing on top of what the other layer 2 solutions are. In this image, we have, our base layer at the bottom, and maybe even below a blockchain, which falls in this distributed ledger category, we have infrastructure for storage and retrieval, something that a blockchain points to and says, we have a large file. That file does not need to exist on the chain, but we can point to it with a cryptographic hash that says this is the unique identifier and only that can unlock or find it. And we point back to storage so that the blockchain does not have to handle that much. So we have platforms, those are the blockchains, and then we have logic built into those chains based on language design and consensus mechanisms. And from there, we then can enable applications. Applications like currency, identity, payments, records, assets, property rights. And from those, the user interfaces with those different types of important applications. So when you have a layer of smart contracts, it sits below what you might think of as what's happening on Bitcoin. Bitcoin, the purpose is to do money. On something like Ethereum, the purpose is to create a generalizable framework, a machine, a virtual machine that can handle any type of transaction, any type of computation, any type of event. And then from there, we can design primitives to say, this is money, or this is a unique asset, or this is an identity. And here is this system for distributing those transactions. Okay, so introducing Ethereum. Ethereum is known as the world computer. And from a computer science perspective, Ethereum is a deterministic but practically unbounded state machine, consisting of a globally accessible single state and a virtual machine that applies changes to that state. From a more practical perspective, Ethereum is an open source, globally decentralized computing infrastructure. Okay, so that's our infrastructure for doing computations at the blockchain level that executes programs called smart contracts. It uses a blockchain to synchronize and store the system's state, and then a currency called Ether to meter and constrain the execution of those resources. So within Ethereum, it's not to solve currency. Actually, currency emerges out of the need to meter and constrain the use of the Ethereum computer, the thing that's transitioning from one state to the next. So a blockchain, we have an immutable ledger of state 1, then a new block is mined and we get state 2, and a new block is mined and we get state 3. The thing transitioning from one block to the next is this Ethereum virtual machine, which updates events, transactions, and then puts them into a block and maintains them in a record. And in that virtual machine, you want it as generalizable and flexible as possible in order to do novel computation. Novel computation can lead to certain primitives like currency and assets and NFTs and many, many things that we have not thought of yet. So we had an original state of Alice, Bob, and Eve and what their balance is. We went through some transaction logic to update what the state was based on a certain amount of economic activity, we would take this transaction logic, bundle it up, um, and then transition from this first state to the second state. And then we would blast out to all nodes participating in this system and say, here was state one, now here's state two, base all economic activity off of this. And then we transition again and continue that forwards. The key point are we want to make this part of the updating of a state as generalizable as possible. With that comes problems, because if you can include infinite loops in the programming language, then perhaps you might introduce bugs, and perhaps that messes with the amount of resources that it takes to compute those transactions, and could lead to other things that slow down the system or um, disrupts the general functioning of a blockchain. And the other key point is that, again, it's not just about money. Money emerged from the necessary design principle for metering transactions, or metering the usage of this virtual machine that updates transactions and events. We want to, because for instance, if we were to spam the network with whatever transactions we wanted to get onto the blockchain, um, and it cost us nothing to do it, then it could very easily result in a malicious actor taking down the system. Let's just spam the computer to do as many transactions as possible, or to take in as much traffic as it can, and then at some level it shuts down. If we were to include an economic fee on each of those transactions, it would deter the actor from being able to spam the network. Or if it was, it would just cost an unreasonable amount of money. So that's what Ethereum is essentially creating, is a market for block space. And all transactions on Ethereum require gas in order to be executed. And paid in Ethereum's native coin, Ether, the transaction fee is referred to as a gas fee or gas price. And that's what's used for token minting. It's used for executing smart contracts and powering any decentralized applications. If we were to look at one particular transaction on Ethereum blockchain, we can see that there is gas used and a gas price here. This fee also is somewhat different than what happens in Bitcoin. Bitcoin, the fee is more voluntary based, whereas in Ethereum, it's a market system, and a fee is required for completing a certain amount of computation. Each computation is defined with a certain amount of what will it cost for us to compute this thing. So when we go big picture, there are things that blockchains must decide on in order to implement in their design principles. One of them is consensus design. Another is accounting design. How will we account for transactions and transitions between states? What language will provide us the foundations for being able to write smart contracts? Or can we limit the flexibility of a language so that we know for sure there are no bugs able to pop into the system? And that's more of on a rigidity side. For Bitcoin, it says perhaps we've implemented the thing that we intended to do. We don't need more flexibility here. And if we do, we can go to a layer 2 in order to do more flexible things. That's turned out to be tough and is still currently one of the major projects on Bitcoin is how do you scale the number of transactions per block? Governance design. How does a community who knows that they want to update a blockchain actually implement a change to that chain? And so um, you can gather in Zoom rooms and town halls and chat it out, and you can have a main developer party who's in charge of implementing some of the community's feedback, or you can bake in governance and voting rights into that smart contract ability. Um, and then from there, establish a process for updating the chain itself with on chain transactions, which is really an interesting idea. How would you design your culture um, for developers, most specifically, and for those for those loud proponents of a particular system? Um, Within Bitcoin, there's a uh, not it's not the kindest reference to the people that are very adamant about Bitcoin, but they're called maximalists, and that's because if you want to push forward the mission of your system, then you put on blinders and focus uh, on only what you can see in front of you. And that idea of maximalism has come up and was kind of coined, I think, by the co-founder of Ethereum, Vitalik Buterin, um, because it's not. Well, let's just say this: there's different cohorts of people who want to advocate for their chain, and they have a financial incentive to do so. And if they can get more people involved, the network grows. And as a network gets more nodes on it and more people involved, the value of that network increases. So, how can you get more people on? Perhaps you sell a specific narrative. The other part of culture design is how do you want your developers to approach development? Do you want it to be rigid, slow, methodical, peer reviewed, tested? Do you want it to be fast, new, add new features, innovative? Um, so those types of things are how you want to design a culture. And again, this is still very much something that's being experimented with. I personally have participated in the Cardano governance process, and it is a little bit. It's both on chain and off chain, which is very interesting. And then there's a lot of different things that we can talk about here with regarding Ethereum, Cardano, Tezos, Arc, Bloxburg, Filecoin, Ronin. I would say it's more important to dive in, or if there's a particular um, if there's a particular blockchain that's caught your attention or your friend's attention, perhaps that's something that you should dive into and be curious about. There's not something that I could provide in in this short amount of time to cover all of what is across our different integrated blockchains. So I've kind of broken it down into different things. I've included the documentation at the top, a general purpose of what it does, some of the founders, the language it's used, a view of the currency, the consensus mechanism used, some trade-offs, unique traits, applications, perhaps a graphic. Let me briefly dive into this graphic. It might help establish what we mean by blockchain ecosystems. Yes, here it says layer 0 is Ethereum because this is a very Ethereum centric graphic. Um, but I want you to think about just the layers here, ignore the numbers. Okay. So at the bottom layer, we have Ethereum. It enables some sort of applications on top. What you might find in this intermediate phase is Well, what we saw pop up in um, the year 2020, in the summer of 2020, was decentralized finance. It was, how can we take programmable money based in these smart contract frameworks and establish new ways of offering yields. Um, this included stable coins, something that the Federal Reserve is exploring, and really established a way to do nuanced and innovative things around finance that perhaps exist outside of banks, outside of the traditional finance system. If you go a level higher, you get to an application layer. And in that application layer, we might see things like a decentralized exchange. So it's essentially an automated market that's connecting two entities on either end and has an automated escrow system. So a smart contract is written. It says once X amount of Ethereum is placed into the contract, match buyer with a certain amount of uh, tokens, a different type of token, and then swap them. And if either one, well, neither one can unlock the smart contract unless the other one defaults. And that logic is written in code and is is an example of a smart contract that's put out into Ethereum. An entire business is based off of that called Uniswap. Uniswap has its own tokens for powering its own network, and you can see how this thing layers in complexity. Um, there are prediction markets. How can we get more nuanced around something that's happening in the real world and have autonomously executing contracts, things that have commitments baked into them that can execute on when some piece of information becomes available, it executes and settles without the needing of a middleman. Those are some interesting things. At the very top layer, we have wallets. Wallets are where a user may interact with the applications and where they may be able to initiate their transactions, sending and receiving, things like that. There's a wide range of centralized and decentralized solutions within any blockchain ecosystem. Um, I think we will continue to see that exist. The ethos is certainly in the direction of let's decentralize everything. Let's put everything onto a blockchain. We don't need anyone else anymore. And I think that direction is a little too overblown. There is always going to be some relationship between centralization and decentralization. Some things do not make sense to be on a blockchain. Um, because a blockchain has a very specific um, set of parameters that would create too much storage capacity or would is not efficient for doing certain computations. All of these design principles are things that are being experimented with currently. It's fascinating to see it play out. I would suggest people diving into an ecosystem just to explore some of those things and begin to put, put recognize the patterns between them. A lot of what brings people to blockchains and cryptocurrencies is speculation. And that's, you know, there is something else going on here. There is a deeper um, value. While I'm maybe hopping around different design principles of blockchains that we've integrated with, there is a different way of looking at this and reframing it from a maybe what brought you in here is speculation or, huh, I saw that in the news, to a deeper economic understanding of it. Thank you for attending today.